Yeah. All right. So I hope it will in there, right? Right, sorry, coded it. All right, so here's what we need now, right? After you have all these logic gates here, we need to be able to take the NOR gate and the NAND. I will do all the NORs here. Take the NOR gate and make every gate, right? Just remember the NOR looks like this, right? And the input and the output for the NOR gate is what? 1 1 1 0 0 1. What's the output in NOR again? 0 0 0 1. Right? So in summary, a 1 always gives you a 0. See that? Every time you have a 1, you have a 0 here. All right. Nice. So that's in NOR gates. So now we have to make all the gates from it. We have to make number 1, we have to make a NOT gate. Then we have to make, well, we have the OR already. We know already. We had to make the OR. Then we had to make the AND. Then we have to make the NAND. And then we have to make the exclusive OR and the exclusive. All right. These are the most popular. Right. First thing, how we taking NORs? How we taking a NOR to make a NOT gate? Real simple. But any idea? For real simple. Any ideas? How to turn this NOR into a NOT gate? Very good. Get rid of one of the inputs. Read that out. So if I remove one of the inputs, watch. 1, give him a 0, 0, give him a 1. You see that? So here's how you do that. You have two options. You could connect up the 2 as 1. See that? A 1 here means 1, 1, which will give you 0. A 0 here means 0, 0, which will give you 1. Right? So that is your NOT gate. Or in some cases, what they did is that they connected here to Earth, I think, here, to Earth. Right? So here it's always 0. 1, 0 is 0, and 0, 0 giving you 1. Right? So either one could work as an OR gate. Either one could work, and not this, sorry. Right? So either this, there's a word OR, right? There's a word OR. So there's a NOT gate, there's a NOT gate. So if you see this in a circuit, there's a NOT gate, right? And they are made from nodes. Okay. Next one is the AND gate. Look at this. Power kits in the center AND gate. You find it close, here the output. We have to do 1 about 1 about 1. But then, and it's looking okay, 0, 0, 0, 1 looking okay, but what's the problem? It what? It's upside down. So what is used to, it would be real good if I can invert all this, huh? If I flip this over, it becomes this. So how you can invert it? Sure. I let me just. Oh, sure. Let me do the OR first. So Saraya will be correct. If I do the NAND, should be wrong. Right? How can you make an OR gate from an OR gate? Or you can make an OR from an OR. Online all okay, right? Get rid of the problem. Yeah. But you can't really move it because you're allowed to, you have to leave it as a NOR. So what you can do here is connect the NOR to a NOT. Now you have a OR gate. You're not, you know, it becomes a O. That's okay? Right? We could do a quick truth table just to make sure. And then I'll go back to my question on how to get the AND. Right? C is the opposite. sorry, C is my NOR gate. E and B, so that'll be 0, 0, 0, 1. D is if I not it. If I not C, I'll get D. Right? So I'll get 1, 1, 1. Right? So that is my OR gate. Right. Now come to the question I asked a little while ago. How do I get the AND? Right? You all told me to flip it over. What will do that for me? What do I want to flip again? Do I want to flip the output or the inputs? Flip the inputs, right? What will flip the inputs to me? Or what? Think about it. What will flip the inputs? Think about it. I want to flip this. So it will match up to AND gate. What is the flipping? What is in a 1 tells 0 and a 0 tells 1? I'm not, right? Ready then? So all I have to do then is the not this, not this. So connect a knot to it. Now, by using a knot alone, by using NORs alone, right? By using NORs, no, we have AND gate. 3 NORs to make a AND gate. Do the truth table and make sure, please. Right? Complete this truth table for my please. Complete that truth table. So you recognize we're using NORs only. Right? We made it. We made nuts, we made ORs, and we made an AND. And you'll tell me how to make an AND. You're supposed to get AND gate, right? One time we were very well, 100 was not AND gates. Which no, make it was the AND gate, right? The output is 0, 0, 0, 1. You know, we're to get out stuff. It was always get out. 2 1 supposed to always get the other one. Everything else is 0. But AND gate. Work out. Work out. Right, so C is the opposite of A. Right, C is the opposite of A, so that'll be 0, 0, 1, 1. D is the opposite of B, so that's 0, 1, 0, 1. And E now, E is C and D into NOR gate. That'll be 1, 0, 0. So we have an AND gate. Right? Ariane, quick question. I want to convert this AND into a NAND. I want a NAND gate now. What to do? Right, so use it. Right, so if I connect this here, not here. That's okay. And because I can do it, I'll just add on to the table. Enough. We have two knots here and no one the next knot on the end. You gotta learn these things, right? Right? This is the NAND equivalent. There's the NOR equivalent of a NAND. Online, are you okay? Kylie, Tinaya. Are you there? Online, are you there? Tinaya, Kylie, Azaria.
I don't know what I want to you think I want to first? I can I think it's seven, but that is seven. Yeah, no, but man,
Everybody okay with that? Yeah. Right? Where we reach now? XO, X no. Right, who paying attention online there? Azaria paying a little, and Kylie, nobody else. Shania not paying attention. But okay with that? The XO and the X no a little bit harder, so I'll give it the NOR easier to remember than this one. Easier to remember than the XO. So I'll give it this and then you'll figure this one out. Right? Watch it here. Right? But what shall I set it up earlier? So what you're doing is you're setting up the circuit like this. This one is the NOR. This is the X NOR. And what you're doing is you join it like this. You join the first NOR gate here. You join the next second NOR gate here. There's 4 in all you need. A fourth, a third here, and a fourth here. Right? So you're putting them 1, 2, 3, 4. Like a cross. And you're connecting it up like this. Watch this here. Watch your connection, right? Yes. Watch your connection. So this output This output is connected here, this output's connected here. This goes here, this goes here. These two are from the initial input. So if the initial input is A is there. If the initial input here is B is down. Right, so it looks like that. So 1, 2, 3, 4. This goes here, these two outputs goes here. A goes here and here, B goes here and here. That's okay? Right? It'll take a little while for you to remember it, right? Let's practice drawing now. Right? And do the truth table here, please. Oh, you'll get it X no. Put up, not there, right? Oh yeah. Do the O and the output.
I see. I see. Yeah.
Seriously, no templates. I can't see that. Do you need templates? I can't see that. Yes, it's a video. Yeah, but after that, it's not. It's a video. It's a lot. Yeah. I think it was better. And at first, I
Yes, that's not all these. Yeah, me, it is not. That's the thing. I do. Se o dia nem nada preço, né? Realmente vários, e aí
So you have to factor in CND to find the product. Because CND, but I mean,
this is what I'm saying,
okay.
right? No. So yeah, this is technically like he and oil. So I don't know what's going to I think season
Yeah, I think we all.
and B institution to get seats and B is just a country. Yes. I think this is. Yeah, I have 1-0-0-0. What? We can win. Yeah. Well, I was there. Actually, she was something. Well, we can actually get next. Do it actually.
Right, so we have all the, right where,
The first thing, yeah.
it's not working out? It's not working out?
So,
Oh, sorry. Why not sure about,
yeah.
like how this one working?
Yeah.
This one alone, right? So A and B. So B go in here, B go in here, A go in here, A go in. See that? So A and B go in here to give you C. Right? So to figure out this, C, I'm looking at A and B to give me C. So that'll be 0, 0, 0, 1. D now. D is A and C. So I'm looking at A and C to get T. So 0, 0, 1, 0. E, I'm looking at
So you look at that.
I'm looking at C and B. So I'm looking at these two to get E. 0. And to get F, I'm looking at D and E. 1, 0. Right? And there's a NOR gate. So watch. This, ignore this. You're looking at A, B, and F. That's a NOR gate. That's okay? Well, X NOR gate. Right? So you're looking at A, B, and F, and you have an X NOR. Are you okay with that? Huh? Right? So if I wanted an XOR, all I have to do here is just squeezing it in here. And NOR gate. That's okay? Adding a NOT gate here. Right? And I will get 0, 1, 1, 2. Are you okay with that? No joy, no Leah. Right? So to get the OR gate, you just connect it down. So what I did here for you is the NOR equivalence area. What you will do for me is you non-equivalent for each one of them. Another go. Right? Are you okay with this? So I want to show you something called a quad node chip now. How to use a quad node chip. All right, yeah. Go homework. I want to see this in your book. I want to see a NAND to make each one of these. Right? The bad thing is you gotta learn that, right? Oh God, what's the inputs for NAND for these? So you're looking at A and C, 1, 0. 1, 1, 0 is 0, 1, 0 is 0, 0, 0 is 1, 0, 1. That's all. Yeah, so you know what gates we have there?
Yeah.
All the gates we have there now. We have to learn the gates, right? All right, next. Right, so I want you to do the NAND homework, right? Let's go back to this little handout thing here. All of those here. You do have one. Right, I'll give you a small help. Do the truth table for this one, please.
So it's not the way they gotta be. No, it's simply.
Or was the same combination? Jonathan Tema was circuit is that? Anybody can guess?
So.
It's just, it looks just like. Yes,
Same area. So which one? Yes, Mark. I was what talking about?
Sebenarnya lah tu bro.
What?
Sebenarnya lah tu bro.
Just join 1, 2, 3, 4 and then connecting it up. What station is that?
Ayo dulu saya.
Check the station, it's up right.
Ini sih.
Okay.
World. That's all. Yeah. So, belum mau yang ini.
This one, no,
Kalau sekarang skin nanti dia skin ada tapi kalau problems. Jadi ya.
Pedro. Alright, someone did some more cases up. Jordan, look it up. Can you see it?
No, I didn't do it. I like.
What's it? You have to work it out, the two tables. What again? X1? What's wrong?
Isi yang gitu. Kita. Kita itu guys kan no hits I had hits.
As 9 games.
Nah,
Nah. You get the
you know idea. Dia dapat semua. Dia menjadi dengan.
No one can back everyone.
Dia macam dia tu kan. Dia buat presiden di sini itu. Dia memang sebagai secret projects. Dia memang sekolah proses. Bukan jadi mana sesuatu.
Ready? Right, remember the same start at A and B, right? 1, 1, 1, 1, 1, 0, 0, 1, 0, 0. Same start. Can I again, true? Everybody okay here, right? See that? Yeah, I need. Wait, that's not
Saya expo. Ya expo.
So that's the non-equivalent of a X4, right? You all done? Number 9 zero kinaka.
So then I know we are going to buffet and the car pass up to the.
A lot meaning for here.
Yeah. Right, remember that nan, let's be careful that. Right, nans, once you have a zero, you're getting a one. The answer should be at XO, right? Ready? Let's check out C. Make it a little smaller, yeah. You'll see enough? Right, C is what? C is some NAND, so that'll be 1, 1, 0. Okay? D is looking at E and C. 1, 1, 0, 1. E is looking at C and B. So 1, 0. And out is what? D and E is what? Right? So they gave that X only.
One, one,
So they can have A and C.
right.
0, 1 given out 1. 2, 1 given out. Right? 0 and a 1 given out 1. 1 and a 1.
I'm not.
But this how this is the same.
So two ones again, yeah. Everything else is here, you know.
1 gives you 0, everything else gives you.
Here's this thing. Because that makes so. How do you distinguish? Oh, one is that X, no, one is that now. Because that's why those put that.
Now look at it, look at the back of it.
Good back.
Oh,
Yeah.
wait, no, it's the same diagram, okay, it's same, but I want to see. No,
What is shape of it? One is a
Oh, one have
curve,
curves and.
one of a straight.
Gradient, let's see what I said.
If you write it,
Gradient, let's see what I said.
as a- you have 1, 1 on top here, I can do. Once you get 0, 1, 1.
Oh. That's something.
Or you have 2 1s on the top. But in the end, you should get 0, 1, 1.
Yeah.
Any questions online there? Are they okay? Right, again, the only way you can really do this. Right, the only way you can do this is by being able to litigate, right? Timothy, are you okay? Right. Sometimes you might have to take your time and draw this one, right? Sometimes the input will look like this. Anybody can tell me what that graph's saying there? Think about it first, think about it first. What does that graph tell you there? See the dark part of the graph? See the dark part of the graph, Divish? See that part of the graph, and down here, and up here, and down, and right?
Yeah.
What else in the graph say?
Kind of
High, very good. 0, 1, 0, 1, 0, 1. And here is what? 1, 1.
0, 0, 1.
You're seeing that? So here what you need now. What you have to do is you have to use the inputs, right? Use these two inputs, enter and AND gate to figure out what the output will look like. What will it look like? 0, 1 and AND gate is what? 1. So you will draw 1 here. That's okay? Watch it again. 1, 1 enter and AND gate is what? So you come down and you draw it here. Are you okay with that? That is basically how you do the graphical pattern. Yep. No? Killer. Here on. Just copying on a boy. Are you okay with that? So do my favor so that completes the NAND and the EXO.
The graph.
Yeah, yeah, the graph. The graph.
Let's say the also minus.
Okay, this is a past paper. That's a past paper right there.
Wait.
So the line is Marian boy.
You what the be right?
Because show you up now. Complete the truth table. Sorry, not a truth table. Complete the graph for NAND and EXOR.
I problem. Problem. Good. Hey, you have about the 16 too. Yeah. No, pero no, sí, no. Jadi kalau main next game setelah that's what it's thing lah. Langsung qualify. So you put it. Football. No, yeah. You were down too. That was funny going down to. I think for more. Did that last time. But again. And it gives it left. Boy, you have to fit in my top. Yeah, I think it's not. And then you food out. Go on. Like, everyone's got, you got one. Yeah, I think you know that one. Yeah. Right, I do note none, right? Dr. None? Yeah. I do note none, right? 0, 0, high. Zero, one is high. 0, 1 is 0, 1 and 1, 1 is coming back down, right? Well, the graph look like that? Yeah, the graph look like that. Done with the XO. Should we come on to do for the XO on? Huh? Whose one is high or low? Zero, 1 is low, so nice, so. So 0, 1 is high. 1, 1 is what? 0, 0, 0 is? 0. 0, 1 is? 0, well, 1, 0 is 1, 0, 1 is what? 1. And then 1, 1. Well, look at our 9 there. Yep. Hurry up. Go that up. Shiny. No. Yeah. Hurry up. Get it up. Hurry up. That's just a lot of the PS sensor. Message on. I'm touching the
Wait, sorry, anything with 0 to 1 is a one, right?
And I am so.
Yeah.
Can you give it up? Timothy. You sure? Yeah, no. All right, so that's how the That's how the AND gate and the XOR gate will work, right? Right, let's go again. So we have an idea about that. Oh, you like it. All right, there's one thing I want to point out here, right? There's one thing I want to point out here. What will happen if you connect two nuts in a circuit?
Let's see what it's started.
Right? So two nuts they cancel off, right? So make a note of that, please. Just make a note that when two nuts are connected, they cancel off each other. When two nuts are connected in well, let's say series, they cancel each other off. When two nuts are connected in series, they cancel each other off. Right? Last thing on that, before I show you how to add binary addition. You look at this circuit here. Right? Whenever you hear quad node chip, that's what you're gonna see. Right? Quad node chip, you're gonna see 4 nodes. Right? And then you could use that quad node chip to make everything. Look at the board. So you'll realize you just need 4 nodes to make anything. Yeah. All you have to do is just connect it up properly. So look at the connection there. The black thing is the little wires. Right? The little black thing there is the wires. What gate is that they made there? So they had 4 nodes and they made a gate. What gate is that?
Because the names of the board, yeah.
Yeah, because a quad node chip, but you only use 2. What it looks like? AND gate. In that earlier? Yeah, why earlier? Why is that AND gate? Huh? Why is the AND gate? What should get it on the board? What should get? And look at the AND gate on the board. The blue, the blue. The blue is the AND, the black is the See it now? So you see the 2 nodes, they turn it into a knot and then connect it into a knot. Yeah. But it's the knot, but they turn it into a knot. Right, they turn it into a knot by singling the input. And if I want to turn this into a NAND, what to do Vikash? How to connect it up and what to do? So I look again.
You want to hear the calls?
So connect what to it up. Take it up and connect it up here. Yeah. We said all right. That's NAND gate now. Right. So we have a NAND gate. All right. So if I give you a quad node chip scalar and connect NAND, that's what you'll do. All right. That's it. Right? The first part. That's the very first part. Take us 2 minutes and then we go into binary. Hey, 2 minutes, huh? 2 minutes and I just get binary addition. But binary, I won't do addition.
0 0 0 1 1 era anel ko the two. Evaluate na lang. Oh, basically ka ko na after check. Nothing. Yeah, right, okay.
Just just put in that those two dollars. Right online, I just gonna have a 5 minute break and then we take a look at binary addition. I give them 5 minutes, for longer ones. Let me go back to them already. Yes, tell them already. Let's take a look at binary, right?
It's a guy. What?
So you know ka? Okay. Sila
Alright, so the next thing we're gonna be able to do, I think people can do this already. We need to be able to work with binary, right? And then of course with binary addition. Right, so one thing I want to remember, binary is in the base 2. Right? So you have 2 to the 0, you have 2 to the 1, and I will go up to probably go up to 2 to the 3. So your first set of values, so you will know to go along. So your first set of values represents your 2 to the power 0 is 1s, right? There's your 1s, 2 to the 1 is what? 2 to the 2 is 2 to the 3 is, right? So based on where the value is, you will know in decimal if there's a 1, there's a 2, there's a 4, there's a 8. For example, let's say I gave it something like this. Suppose I gave it something like that. This is a binary number, right? This binary number has a decimal equivalent, right? It has a decimal equivalent, and the way you work it out really easy. 1 by this, 0 by this, 1 by this, 0 by this, add it up. Right? 1 by 1 is 1. 0 by 2 is 0. 1 by 4 is 0 by that is 0. So 0, 1, 0, 1 is the binary digit. Sorry, is the decimal 4. Right? Yes. So the equivalent of 5 is 0, 1, 0, 1. Okay with that? We would just do like the first 1, 2, 3, 7. Right, go more than 7, but we'll go 4. Right? So we go to 14, 15. Right, but for now I'll just go up to 7. But okay with that? You all okay with how I convert this binary to that? Just do my favor. Tell me what it says here. How much is that? How much is this in decimal? Hello, okay with that? Okay, guys? Nearly how much it is? How you get on? Ay, babukin original niya. Once again. That one, are you okay with that? So it's 8. 8 plus 0, 8 plus 0 plus 2 plus 1. Right? That's 11. Shivish, what's this here? Huh? 15. Right? Do me a favor. Right? Do me a favor quickly. I want you to write 1 to 15 in binary. All right, well, 1 to 12 carries more than that. 1 to 12. Right? 1 to 12 from decimal to binary. 1 to 12. Quick. Oh, you want me to start? Okay. 0, 0, 0. Okay. Okay, what more? You do your thing. Yeah. No.
Okay, sorry.
Right, so 1 will be 0, 0, 0, 1. 2 will be 0, 0, 1, 0. 3 will be 0, 0, 1, 1. Yeah, Kalaya. 4 is what? Hey, to you know. 4 is how much?
0, 1, 0.
Well, look it up. 4 is what?
0, 1, 0, 0.
Right, 5 will be 0, 1, 0, 1. 6 will be 0, 1, 1, 1, 0. 7 will be. Right, and so on, right? 8 will be this. 9 will be this. 10 will be this.
9.
Ask if I step wrong. There's 8. Huh?
1, 0, 0.
And 8 is the one.
No. So 9, correct. 9, no. Yeah, correct.
8 and 9 correct?
Oh, yeah, it was the line.
Yeah, you're probably not lining up so good.
That makes sense.
9 is
So there's 8, there's 9, there's 10, there's 11, and the last one is 12, right? Let's skip one more. 8 and 4,
1 0 0. 1 0.
there's 8. This is 9,
It's about 11. 10.
this is 10,
1 11 1 0 1 1.
right, I'll leave it out. That's 11 and that's 1. Good. What we have to do last thing, I'm not gonna show you the circuit behind it, but the next thing that we have to do is do binary addition. Right? Everybody remember how to add, right? Yeah, Marianne? Suppose we had 74 plus 98. Right, add again. 4 plus 8 is 12. Right? 1 will come here. Sorry,
So did you follow that?
sorry. 2 will go here and the 1 will go here. Right? And then you have 1 plus 7 is 8 plus 9 is 17. That's okay? So there is a sum and there's something that we carry in here. Correct? So there's a sum and a carry. So when we do binary addition, right? Binary addition is the same principle. All right? So I want you to remember this. I'll show you all that. Forget that.
So you kind of talking that's.
No, because you wouldn't get the anyways, I'm gonna show you something. So in binary addition, something looks it might see something like this. Let's do a 3-bit addition. Right? When you add in, this is 1 and 0. 1 and 0 is what? 1, right? 1 and 0 is 1. That's 1 in binary, right? So what will happen? The 1 will go here. So the 1 is like a sum, and the 0 is like your carry, right? But you're going to carry that one. Let's see. You okay with that? So 1 plus 0 is 1 in binary. This 1 will come here, the 0 will go there. What about 0 plus 0 plus 1? That'll be 1 again, right? So the 1 will come here and the 0 will come up here. Correct? Then you have 0 plus 1 plus 1. In what's that in binary? 2. Right? And 0 plus 1 plus 1 is 2 in binary. And 2 in binary is 1. That's okay? Right? Let's try a harder one. Huh? What is here? Right? 1 in binary is 2. Right? But to write 2 is what? 1 0, right? So the 0 comes here and the 1 comes here. 1 1 1 is 3, right? But 3 in binary is 1 1. So 1 will come here. 1 will come here, and then this one will come. 1 plus 1 plus 1 is. So the answer is 1 1 1 2. Right? What we have to do now is we have to create a circuit that'll do this for us. Right? So what you will recognize is some of them have 3 inputs, some have 2 inputs. So we're going to use something called the half adder and the full adder. For both read up on half adder and full adder. Right? Shivish, you will explain the half adder. Divish, you will explain the full adder. Next. Right? So all I want you to do is just read up on the half adder and the full adder. That's what we're doing next day. And we'll build a chip. And we can probably play around with one of these simulations as well. Right? We can probably play around with one of those simulations so you can